What's up, everybody? This is Eddie with Flex Machine Tools, and welcome to our latest episode of Flex and Friends, a videocast experience series where I'm going to be sitting down, hanging out, chatting, and picking the brain of the industry's best, brightest, loudest, proudest, most passionate, and profound thought leaders. And we're going to be talking about everything, you guessed it, manufacturing. So today we're going to have a little bit of fun, and we're going to be doing the robot as we talk with one of our good friends, Kel, over at Robotics. So we'll allow him to introduce himself here in a moment. But before we get started, make sure following this episode, head on over to flexmachinetools.com. Check out all the cool things we have on our website. Also, to stay up to date with all the amazing content we're producing, you can find us on YouTube, Facebook, LinkedIn, Instagram, and we're even messing around on TikTok. Hey, but without further ado, let's bring in our guests from the backstage, get a little bit of introduction, and get things rolling. All right. Look at this guy, Kel. He is with us. He's in the studio. We're hitting it hard today. Man, thank you so much for joining us today. First off, how you doing, man?
I'm doing great, Eddie, man. I'm stoked to be here. This is awesome.
Oh, yeah, I'm excited. We got a lot of really cool guests, but I've been super excited for this because robotics are such a huge thing. Automation is such a huge thing. And I know that you are definitely one of the industry thought leaders. So we'll be picking your brain here in a second. But before we get rocking and rolling, since we are humans, let's learn a little bit about Kel personally and professionally. What do we need to know, man?
Definitely. So I'm Kel Guerin. I am co-founder and currently chief innovation officer at Robotics. Robotics is a company that I founded with my co-founder Ben Gibbs in 2016. And our whole mission is to make it easy to use robots in a manufacturing setting, which have been typically these really hard things to use. Our goal is, let's make them easy. Let's empower people to actually use these systems just like they use any other tool. So I kind of got my background in a lot of different robotics spaces. So I worked on robots that go to the moon, robots that are used in surgery. We worked on mining robots, all of these sort of different fields. But what was interesting about them is the fact that, like, it sounds crazy, right? You're going to send a robot to the moon. It's going to drive around. That sounds like a hard problem. Well, it's actually
right.
It's actually a fairly solved problem. The Russians did it in the 60s, and not that it's hard. It is hard, but when I saw all these different robots, ones that it needs to drive around on the moon, one that needs this sort of spidery looking thing that goes into a mine, a robot that can fit inside the human body and do interesting things in there. What I saw is how does a person interact with these devices, right? How does a person control a robot on the moon when it's 10 seconds of light, faster than light travel away, right? Or light travel away, right? I move the joystick and the robot moves 10 seconds later, and then 10 seconds later, I see the video of it. I can't drive a robot around like that, right?
You can't.
Yeah, or I've got a mining robot with 30 different joints in these big spidery legs. Well, I've got one hand that can move a joystick around. How do I control that, right? So it became this interesting problem of how does a person who might be an expert, right? An astronaut, a miner, a surgeon, right? How does that person use that robot and work with that robot to do the thing that they need to do, mine, do surgery. And that's what got me into the manufacturing space, because manufacturing sort of had that same problem. You have a lot of people in manufacturing who are experts at doing the various processes that they do, but they're not robotics experts. And a robot is obviously a tool that can help in manufacturing,
right?
But the challenge is how do you get what's in that guy's head into the robot so that the robot can do that work, and then that person can go off and be more valuable than standing there in front of a machine doing stuff, right? So that was sort of the question that preoccupied me when I did my PhD, and then we ended up building technology that sort of solved that made it easy to program robots, and that's what we spun out into Robotics.
No, this is great. And I kind of want to take a step even back with that. You gave us a little bit of preface, if you will, but really and truly, how did you specifically get started with Robotics? Sounds like a great background, and you clearly know what you're talking about. No one can challenge that whatsoever. But what got you there? What brought you to this incredible journey that you're now just running full steam ahead with?
Totally. So I'd actually I wasn't even really thinking about robots when I was going to school and stuff like that. I always wanted to be an engineer. I always wanted to make stuff. That's really my passion, is making things. funny that I end up in manufacturing where that's the whole game, right? Which makes me really happy.
Here we are.
Yeah, exactly. It's super fulfilling, right? But I never thought about robotics. I was more interested in electronics and things like that. But I ended up going to Carnegie Mellon and walking through this robotics lab, and they had all of these amazing things, all these amazing devices, and that was a field robotics lab. So it was all about robots that would drive around, except this lab had sent robots to the South Pole. They'd driven robots through the Atacama Desert. They'd send robots into the Arctic, right? All of these down into volcanoes. Like, if you ever seen the movie Dante's Peak, like the robot that climbs down into the volcano in that movie is like based on the one that this lab made. So super groundbreaking stuff, but it was all like, it was so, it just opened my eyes. It wasn't just like, oh, I've seen, like Rosie the Robot or robots on TV, or, which you're always, as a kid, you're always going to be passionate about. It's like, oh man, that's so cool. You're watching Lost in Space when you're 4 years old, and of course the robot looks awesome, right?
Oh, yeah.
But you don't get it, right? And you don't get what it is and what it can be and how it can help humanity. And so I walked in this lab and I was like, oh man, this is incredible. Like, I see where these things can go. I see the value that these things can have. And I just completely shifted gears. I started working on a team where, again, we were starting to work on that space robot. The idea was that it would fly to the moon, drive around, take high definition videos, send it back to Earth, right? That was the game. It was a Google Lunar X Prize project. So there was like a big pile of money if you actually figured out how to do it, right? So that really got me into thinking about robots, not only just like them as this cool piece of technology, but what they could do and how they could change the world. And so it's been really fulfilling as I've sort of had that journey towards where I sit now, from mostly in the manufacturing space, because that's where robots are being used today, right? That's, we've got, there's a couple of fun products like the Roomba and things like that people have in their houses now and stuff, but most robots in the world are in factories, making stuff. And so so if that's where they are, and that's the value that they're providing right now, how do I make that the best it possibly can be? That was really sort of where this journey has led for me.
Man, and a journey it has been, and I'm sure there's lots of amazing ups, downs, stories, highs, lows, peaks, valleys, and all that fun stuff. And so, but here we are, and so transitioning into the now. What has Ready Robotics been up to lately? Like, what's going on over there, man?
So we've been it's been a crazy year, because
I bet
Ready has always been about building a product that makes robots easy to program. And a couple of years ago, we released the first version of our Forge software, which is designed to make it so that if you have a robot, it's a very easy to use programming system where no matter what your training level is, even if you've never seen a robot before in your life, you should be able to sit down and in 10 minutes be able to program a robot. And then in a couple of hours, have the robot doing something really useful. And then in a day, potentially be running a production task in a real factory with that software, right? And so the last couple of years have been a lot of iteration on that idea. And in May, we released our 5.0 version of Forge, which is what you're seeing in these videos. And that's sort of the culmination of all of that effort. It's just, the culmination of 35 people working nonstop 18-hour days for 12 months to put this product together. And it's not just about making the robot easy, but it's also about making any robot accessible. Because a huge part of the problem is that all of these robots out there that are used today, they're all different and they're all hard to use. And so Forge 5.0 for the first time makes them all this common thing that's actually accessible. And so we just released the 5.0 version of that. We're also looking to the future with developers. We're about to release our SDK. So it's been very busy, sort of like as that product has matured and as we've been building it out into sort of the latest version. So that's really what's been going on with us.
No, it's exciting to watch everything that's happening. You really do a great job of telling your story, and your brand has strong representation in the space, obviously. And so to that point, even though you're solving a lot of problems for that space, there are still clearly some struggles within the industry and, you know, within the robotics world. So as a guy who lives, breathes, and just sees this every day, what are some of those struggles that you're still seeing in this world that we have yet to overcome?
Yeah, totally. So think about robotics like computers, right? And it's funny because people sort of think about robotics as this sort of fancier, separate, more complex thing, right?
Yeah,
But if you look at the history, let's go back to 1961, right? 1961, first industrial robot that was commercially available that you could buy like more than one of, right? That wasn't just a science experiment. Hit the market, right? Called the Unimate. Same year, IBM came out with the IBM 650, which is probably the first mass-produced computer, okay? Fast forward to today, right? I see a lot of computers and I don't see a lot of robots, right? So what happened?
That's a true story.
Right? Yeah, what happened in those intervening years where computers now redefine the world and robots are still sort of, well, they're there, we use them and stuff, right? But it's not like this defining thing. So if you think about the what problems we've had to overcome, if you look at the a key piece of it is usability, right? So if you looked at like the 1970s of computers, you have a mainframe, you have to hire some dude with a PhD in computer science to do anything useful with a computer, right? Mm-hmm. Fast forward to 1986, you've got DOS, you've got, you know, beginning to have the beginnings of Windows, right? You have the Apple PCs, right? You have personal computers, right? Computers are easy to use. They're easy for your mom to balance her checkbook at her kitchen table, easy to use, right? They're not like, you know, they're accessible to everyone. And as soon as a technology is accessible to everyone, everybody thinks of cool stuff to do with it, right? And you get the kind of, you know, progression that we saw in computers where people developed new software, people developed, you know, new applications, people started coming up with creative ideas how to use these tools. And it all came out of the fact that, one, they were accessible, they were easy to use. And two, there were platforms like Windows and DOS that sort of made computers this sort of common thing, right? Because before then you had Atari, you had Commodore, you had all these computers that they were all different, right? Windows comes along and they all run Windows. And now today it's the same thing, right? They all run Windows. If you're not sitting there worrying about, oh, well, if I buy a Hewlett-Packard computer versus a Lenovo computer, I'm gonna have to learn it all over again and stuff, right? That's just not an issue.
Valid point.
You plug in your mouse and they work with both. It doesn't matter, right?
True story.
Robotics are sort of in the 80s in that same way, right? Robotics today, there's tons of robots out there. They're all difficult to use, or maybe the 70s is better, right? They're all difficult to use. They're all different, right? So if you buy like one of the robots behind me, a universal robot, it has one programming system. If you buy a KUKA robot or an ABB or a FANUC or whatever, it's going to have a completely different set of software that you have to learn. And it's hard to learn it. It's 70 hours of training in general to learn it, right? Yeah, so it's hard and they're all different, right? So from a user standpoint, you have to be an expert in order to use this thing. And from a developer standpoint, because again, why did computers become so big? Because people built stuff on top of them, right? People built Word and Photoshop and Premiere and, you know, all the tools that we're using right now, Zoom, right, to talk to you guys, right?
Right, yeah.
They built all of that on computers because there was this sort of common layer. Well, you can't build anything on robots if they're all different. And that is really the sort of problem in the robotic space that we're thinking about. The problem sort of more largely in the world is the fact that we need more automation, right? COVID, we've seen what happens to the supply chain of the world when it's based on human labor and people get sick and can't go to work and things collapse, right? Mm-hmm. Automation is an obvious fix for that, right? Because, you know, robots can stay in the factory and do their thing and we can stay home and not, you know, be around other people and all of the stuff that, you know, we had to do during COVID. But the issue is automation is so difficult that we can't implement it fast enough to actually keep up. So even though there's this massive demand, we can't implement it fast enough to keep up. So it's that problem. It's also the problem that there's a huge skills gap in manufacturing. People can't find enough skilled labor. I mean, I'm sure if you're a manufacturer listening to this right now, I'm sure you have an unfilled position open that's been open for at least 6 months, right? Chances are you have a second shift or third shift you can't fill. You have a machine operator you can't fill. In general, most companies that are operating today in the US have that kind of thing. We can't find good people that know how to do the work, that'll do it reliably at 3 o'clock in the morning. Well, a robot can do that, but we also can't find the people who are skilled enough to put that robot in place, right? So it ends up being this catch-22.
Sure. Which makes sense. And obviously those are some real life examples of those struggles happening. And we're talking about this universal programming. And so I'm curious, Kel, like in all reality, what is that even like, what does universal programming mean for manufacturing as a whole? I'm sure it would be an absolute game changer and is, but like to what magnitude?
Well, I think it really just unlocks automation, because think of a machine shop today, right? They have a process. They're putting a piece of metal into a CNC mill, they're taking out again when it's a different shape. That happens in countless places across the country, all day long, right? Those, the people doing that could be setting up new machines. They could be setting up new processes. They could be doing quality checks. They could be doing metrology, right? They could be doing all the things that are hard to automate. Okay. Yep. Putting a piece of metal into a machine is straightforward to automate. But if the robot is complicated, then it's a non-starter, right? So now let's imagine that I can take the person who was putting that piece of metal into that machine, and in 15 minutes, I can teach them how to program a robot. And they, now empowered with that new tool, right? Because it's all about the tool, right? The tool lets me do new things. The tool as a human gives me new capabilities and strengths and empowers me to do more awesome stuff, right? The robot now becomes a tool that they can use to do that task, so that now they're valuable elsewhere. And we've had exactly that happen, where we've gone into a medium-sized manufacturer. They had a machinist who was losing his mind because he was in charge of 5 CNC systems, and he was programming all of them. He was just a genius at programming these machines and keeping them running. But he spent most of his time tending, like doing 20-second cycle times on one of the machines. And anytime he went to go fix one of the other ones that was running on a longer process, his productivity on that machine would just plummet.
Right. Yeah. Okay.
And you go to this work cell, and there's just piles of unfinished parts, like a massive backlog of unfinished parts around him, right? That's something that probably a lot of the people listening to this could relate to, is that you have some bottleneck because it's just, you can't make it work, right? In a day, using our software, because we've made it easy for anyone to program a robot, in a day, we wheeled up a robot to his machine. He programmed it himself because he wanted to. He was like, look, if it's going to touch this machine, I'm going to understand how it works. In 2 hours, he was programming the robot. And by the end of the day, that robot was doing that tending. And he was off happy as a clam doing his actual job, which was running these other machines, making sure they worked, setting up new processes. And that backlog was fixed, right? So that's as real of an example as I can get of how making a robot easy to program, even though that sounds like some sciencey thing, right? Actually impacts the bottom line of a manufacturer, right? And let me give you another example. There was another company we had called Alleycat. Had same problem, right? They're a manufacturer. In March, beginning of COVID, they make ventilator components. They are underwater because they have so much demand for what they're making, right? They can't find a second and third shift operator for this process, making these components, right? So they're just drowning. In 3 days, they got one of our systems powered by Forge themselves. They didn't even call our support line. Like, we were there, we were ready. We were like, hey, let us know if you need any help. We're here. We're happy to get on the phone with you. They just read our manual, which is super easy, right?
Right on.
And they programmed that machine in 3 days. In 10 days, they were running lights out by themselves. No phone calls. I haven't even heard from them yet.
That's
right?
nuts.
We're like, what's going on? Hey guys, how's it going over there? Right? Nothing. 10 days they were running lights out. They paid off that system in 30 days. They got an ROI of a month because it was a critical process that they had to automate it in order to fix. And because they were able to automate it themselves, it was a game changer for them. So that's really the value of that ease of use that I'm talking about.
Two super relevant examples, straight up at the spindle, getting ROI specifically with it. Expect nothing less from something like that based off of what it is that you're creating and you're doing and implementing there every single day. And then, so you gave us two examples of individuals who could use this well. But for those who think, okay, well, maybe this is just for job shops, or maybe it's only for mid-market, or hey, this only works more in production shops. What arguments can you shut down, and what points can you make to somebody who would bring that to your table?
Sure. So let's just go from the bottom up, right? Small machine shop. It's all about empowerment there, right? You have operators that are 100% capable of programming a robot. You don't even know it yet. That can set up a job very similar to Alley Cat in a matter of hours or days and be running production parts, right? So for a small shop, it's the ease of sort of entry, right? Like I can get a robot in and in less than a week be running production, which is was unheard of. Okay, and also it works for high mix, low volume, because a lot of times when people think of automation, they think, oh, I have to be running volume, I have to be making 1 million of something, or else it's just not worth it, right? And that's how it was for a long time. But if it takes an hour to program the robot, okay, or it takes, if you've already programmed it for one SKU and it takes 10 minutes to program it for a second SKU that's pretty close to the first SKU, then you can think about running the robot for 24 hours and making 500 of something and then switching over to something else, right? You can actually think about being that agile with a robot. And especially if you have recurring SKUs, right? If you program it and then 2 weeks later, you're going to do 500 today and 2 weeks later, you're getting another order for 500, you're like doing just in time, right? That's perfect, because you just pull up the program and in 30 seconds, the robot's ready to run that other SKU, right? So the changeover time is so low and the programming time is so low that you can actually do high mix, low volume, right? Let's go all the way to the other end of the spectrum and talk about like the enterprise, right?
Let's do it.
Most enterprises that do manufacturing are conglomerates, right? A lot of them, right? Like one of our other customers, Stanley Black & Decker, they're a conglomerate. They're a company of companies, right? So on the factory floor, they actually look like a small manufacturer. But they also care about the fact that if I'm a big company, like an enterprise, and I've got 50 factories, I've got all of those factories that I might have slowly acquired over time. All of those factories might have different robots because they've had different relationships with different integrators. They've had different people there. They've got this huge sort of snarl of all of these different systems. What they're looking for is the other piece of value that we provide with Forge, which is that common operating layer, right? Because now all of their robots at all of their factories are going to talk the same language, which means now, besides the fact that a factory can pick the right robot for the job, right, without having to worry about having to learn anything new, the corporation can go, hey, let's build a center of excellence. Let's centralize expertise. Let's train all of our people on the exact same software so that they can all use all of the robots that we have, which is a huge economy of scale for them, right? That a huge cost saving measure, because now they have sort of everything is the same and everything is easy, right? So that now if they don't worry about, I've had so many companies talk to me about like, oh, well, we have to send Frank from this facility to this other facility over, fly him there, urgently, because he's the only one who knows how to program Yaskawa. And that facility has a Yaskawa robot, and all the people there are FANUC guys. And so we have to fly him in special for that. That kind of stuff happens constantly.
I bet.
And so it allows for a larger company, and mid-market is sort of the best of both worlds, right? It allows for these companies to strategically plan around their robotic fleet, because now it's this common thing rather than a bunch of different stuff. And then intrinsically they get the value of, hey, it takes hours to set up, a bigger automation project, especially for the larger companies. A bigger automation project that took months now takes weeks, right? That's why they care about those two things, that ease of use and that common platform that Forge OS provides.
No, solid examples indeed. And then, so with that, one of the final points, which first off, I appreciate you addressing each of those individual buckets and why it's relevant, because that makes a lot more sense for individuals who may challenge the relevancy in one segment versus the next. So that was perfect. And like I said, addition to that, big buzzword, man, automation. You mentioned it before, and I wanted to be able to kind of readdress that because I know it's something that I think you can speak very, very well to. But to that point, it's meant a lot of different things over the last couple of years. So we're going to take this two different directions. One being, what does automation mean in 2021? And then we'll talk about the future scope of what that's going to look like. But let's start, Kel, what does that mean in 2021, man?
Yeah, I think, I mean, if there's the two things that I hear about the most are, I can't find skilled people and I've got bottlenecks because of it, right? And we're sort of like the 2020 could literally be called like the year of the bottleneck, because that's what happened.
Nice.
Right? Like you had, from a supply chain standpoint, you had that. From a manufacturing standpoint, you had that. From a logistics standpoint, you had it. We can't make enough. We can't ship enough. We can't sell enough. People can't get enough. We're hosed. Right? That was 2020.
Yeah.
Right.
That was a great breakdown, by the way.
Right. So automation is about, in my mind, right? It's about two things. One is breaking those bottlenecks, because an automated system has capabilities that people just don't, right? It can sit there and tirelessly put those pieces of metal into a machine all day long. It'll never make a mistake, right? It'll never need to take a break, all of that stuff, right? But more importantly, it's about empowering people, right? Automation, since the history of automation, has been about making people better at what they do, or making certain things that people were the only ones who were capable of doing it, making it so that they didn't have to do it anymore. And there are so many back-breaking, mind-numbing, the 3Ds, dull, dirty, dangerous tasks out there that people do, where they want nothing more than to be doing what they actually are paid to do, which is creatively solve problems, work with precision machines where their knowledge equals how good of a component is going to come out of those machines, right?
Right.
And solve problems for their employer, or if if their business, solve problems for their business, right? That's what people want to be doing all day long. And automation can enable that, right? Automation is a tool, right? It's just like an angle grinder, right? Which is why, not to dig into the, do robots take jobs things, but first of all, 100% they don't. If you look at the actual numbers, most companies who put robots in place end up hiring more people because they break that bottleneck and they're making 3 times as much money. So they go bid out on another job and they hire more people, right? So that's sort of a fallacy. But the whole point is that it's about empowerment. Robotics are another tool, right? Nobody's ever gotten mad at an angle grinder for stealing jobs. It's better than a file, right? It's more efficient. That person is more empowered to be better at their job. And a robot is just an extension of that. Automation is just an extension of that. So by, and I come from the perspective that we're trying to make robotics easier and more accessible.
Right.
And therefore, in that vision, automation is a huge empowering tool for people so that they can use this incredible tool, this robot, to do the things that are not valuable for them to be doing all day long, so that they can focus on the things that are valuable for them to be doing all day long. That's fundamentally sort of where we're at in 2021.
Sure. So second part of that question, as we kind of wrap some things up here. So what does that mean for the next 5, 10, 15, 20 plus years in your mind?
Well, I think that it's going to be an interesting time, because robotics is sort of still, I would say it's still in its infancy. We're still in the 80s, right? It's kind of hard to predict what it's going to be in the 2000s of robotics, right? 20 years from now. But I think that the capabilities of robots will get a lot better. People think that like we're going to have like really serious AI and stuff like that in 20 years. It's going to take longer than that. I'm sorry. It's hard. It's really hard. When you start, make a robot that walks up the stairs. It's hard. There are some seriously hard, or has a gripper that works as well as my hand. I was just talking with somebody yesterday who's like, has one of the leading research labs in the world on building robot, hands. And it is hard. So I think that technology is going to improve slowly over time. Sure. But I think what I just mentioned will continue to be true for the next 10 to 20 years, which is robots and automation are going to be an empowerment for people, especially as people take ownership of it, right? The reason the computers are such a thing is because we as people, as humans on the planet Earth, took ownership of computers and made that technology our own and started building incredible things with it, and creating tools for everything, right? Like every industry on Earth, tools for social change, tools for communication between people. All of that incredible stuff came out of the fact that people kind of own computers now and can do amazing stuff with them. That transition from robots being this sort of scary, complicated, boring sounding thing to something that we collectively as people own and can build incredible stuff with, that is what's going to define the next 10 or 20 years in manufacturing and in, a lot of other markets as well. So I'm excited for the next 10 and 20 years because the robots are going to keep getting better. The technology is going to keep getting better, but people are going to start doing really insane stuff with it that I haven't thought of yet. That's what's exciting for me about the future.
No, absolutely. And then speaking of the future, just for laughing purposes, are you ever afraid that you're going to make this software so easy that you're going to accelerate the process of the Terminator becoming a reality?
I knew it. I knew this was coming. No. No, because again, like try making a robot that walks up the stairs. Like there's a lot of hard problems out there to solve that are just really difficult. Like we really take for granted, and this is why it always comes back to people. We really take ourselves for granted and what we can do, like what we can do with our hands, what we can do with our minds. That's not an easy problem to solve. It's not a remotely easy problem to solve. And so, yes, in the far future, we 100% will have robots that could act like us and do things the same as we do. And then we'll have the problems with those devices that we already have with each other, right? And we'll have to figure that out. But for right now, it's not a concern. And we need to focus on how can that technology improve us as people and take what doesn't need to be on our plate off of our plate so that we can put what we want onto that plate. That's really what it's all about.
I love how the robotics thought leader has talked so much in this conversation about human capability, human potential, human ease of life, and just quality of life in general. I love how those have been staples of this conversation and not robots. No,
that's what it's all about.
No, and I love it. That's how I know that you're definitely a thought leader and passionate about what it is that you do, because that's where your head and where your heart is. And it's awesome to see the things that you're doing. And so for those who want to keep in the loop with all the cool things going on at Ready Robotics, man, where can we stay up to date? Where can we get more info? Where can we check you out?
Absolutely. So if you're sort of on the manufacturing side, you want to learn more about robotics and how robotics can redefine your business, frankly, go to ready-robotics.com. That's a great place to start. We also have a website called ready.academy. That's just the web. That's it. Just ready.academy. That's where all of our educational resources are. They're all free. Go and learn about robots right now. You don't have to do anything. You don't have to pay anything. Just log in and start learning about, literally taking our courses that we give our customers on how to use our stuff. And then there's also ready.market, which can give you, if you are thinking about, doing machine tending or another common process where robots are used, chances are we already have a pre-built cell on ready.market where you can go, you can download the bill of materials, you can download the drawings, you can download all of it, and then you can see exactly what you need to buy, and you get connected with the people who will sell it to you to build that system out, and then you can do it yourself. Like it's all about empowerment, whether it's education or physically putting the stuff together. That's what our website is all about. And then you can also follow us on LinkedIn. You can follow us on Twitter. You can follow me on Twitter, Kel Guerin, if you want to hear about all random cool robot stuff. That's kind of what I put up there. But yeah, just, reach out, stay engaged. It's a whole new world of what robots can do for you guys.
No, it's incredible. And then what's also incredible is you taking your time to really share your passion for not only robotics, but the problems that you're solving in manufacturing. It's really nothing short of incredible. I'm truly humbled by everything we've been able to discuss today. So for all of you viewing this, you know exactly where to get more information. I would highly suggest you follow them on their socials, check out their website, Free Academy, learn about robots for free. It's crazy. They're kind enough to do this. So go ahead and share the love, and we're going to continue doing the robot. We thank you so much, Kel, and thank all of you for checking out this latest episode of our Flex and Friends videocast experience series. So hey, you all stay awesome, stay flexing, and we will see you next time.